Hi, it's MP the tutor again, and today we're going to look at negative and fractional indices. So I'm going to start off with kind of basics of something like 3 with a little 2 just means obviously 3 times 3, and 3 times 3 is 9. And 2 with a little 4 just means 2 times 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8, times 2 is 16. So what about with negative powers? Well, positive powers are multiplying. The negative powers are clearly to divide. So if I have a 3 to the minus 2, that's like going divide by 3, divide by 3. But this is a little bit weird because we don't really have a number here. And that's because it's a 1. Now, a bit like here, I could put, if I put the equal sign and put the equals here, I put 1 times that. That's the same thing. But we normally, with negative powers, don't write 1 divided by 3 divided by 3, because that's a bit, well, weird. Rewrite it as a fraction. So it's like 1 over 3 squared, which is 1 over 9. If we have 2 with a minus 4, that's 1 over 2 to the power of 4, which is 1 over 16. And if I had, let's go for sheep, we don't have sheep. Oh, that's a really awful sheep. The power of minus 3, well, that's just the same as 1 over sheep power 3. With negative powers, another thing it's doing really is doing what's called the reciprocal of our equation. Now, the reciprocal is a flipping of the fraction. So if I had, what is the reciprocal of 3? Well, the answer is 1/3. But 3, you could view it as 3 over 1, and that then turns into 1 over 3. So if I do a little table of number and the reciprocal, well, let's go for 4, and the reciprocal of 4 is 1 over 4. If I've got a third, the reciprocal of a third is 3. And really, you could think it's 3 over 1, but we don't bother doing divide by 1. If I want the reciprocal of, let's go for 10, that is just 1 over 10. If I want the reciprocal of 2/3, well, that becomes 3 over 2, which I could make that as 1.5. If I went, what's the reciprocal of 5 over 4? Well, the reciprocal of 5 over 4 is just 4 over 5. So as you can see, we're just flipping fractions. So if I went 5 over 4 to the minus 1, well, that is just 4 over 5. So what the negative power is doing is flipping the fraction. If I went 4, just normal 4 to the minus 2, well, what that is it's going to flip the fraction. So it's going to be 1 over 4 rather than 4 over 1 to the power of 2. 1 to the power of 2 is 1, and 4 to the power of 2 is 16. And it's flipping a fraction. So if I went 3/4 to the minus 2, well, then that is the same as 4/3 to the power of 2. So it's just flipping that fraction. So this negative power flips the fraction. And then we do 4 squared is 16, and 3 squared is 9. And that could be simplified to be like 1 7/9, but I'm going to leave it as 16 over 9. We actually prefer improper fractions or top-heavy fractions over the mixed fractions. Let's do a couple more. If I do 4/9 power of minus 1, well, that's just 9 over 4. So literally just flipping it and power of 1. Or let's go for 2/3 to the minus 4. Well, that's the same as 3/2 to the power of 4. 3 to the power of 4, we do 3 times 3 is 9, times another 3 is 27, and times another 3 is 81. So you get 81, and 2 to the power of 4, which we've done before, is 16. And that would actually simplify to be, or another way to write it is 5 and 1/16. So those are sort of my single, well, integer powers when they are negative powers. So if I write a couple of questions, and then I want you to have a go. So give it a moment and output. So have a go at these questions now, pause the video, and we will then work through them and give you all the answers. Okay, so let's have a little look at this. We have 5 to the minus 2. Now, what this really is almost like 5/1. We flip the fraction to be 1/5, and we square it, which 1 squared is 1, and 5 squared is 25. If I have 1/3 to the minus 3, that's like going 3/1 to the cubed. 3 cubed is 27/1, and then 27 divided by 1 is just 27. 3/4 to the minus 3, well, that's then 4/3 cubed. 4 cubed, so 4 times 4 is 16, and 16 times 4 is 64. 3 cubed is 27, which leave like that. And the final one is 3/2 to the minus 5. Well, that's the same as 2/3 power of 5. 2 to the power of 5 is 32, and 3 to the power of 5 is 243. So those are our answers: 1/25, 27, 64/27, and 32/243. So we've had a little look at the negative powers, but let's have a little look at the fractional powers. Now, if I have 16 to the power of a half, that's just the same as the square root of 16. And the square root of 16 is 4. Or what about if I had 27 to the power of a third? Well, that there is the cube root, and I'd write this like that. Cube root of 27, and the cube root of 27 is 3. Or even something like, let's go for 81 to the power of a quarter. Well, that's the fourth root of 81, which is also 3. And I'm kind of ignoring things like plus and minuses, which might turn up on these things as well. I'm just dealing with the numbers. If I had fractions, like, I don't know, 4/25 to the power of a half, well, that is the same as the square root of 4/25. And the square root of 4 is 2, and the square root of 25 is 5. So let's have a little look at some other ones. So what about we have 9 to the power of 3/2? Well, 9 to the 3/2 is actually the same as 9 to the power of a half cubed. And that's then the same as the square root of 9 cubed. The square root of 9 is 3. So then we have 3 cubed, and 3 cubed is 27. Now you can, in theory, go the other way around. So you could have 9 to the 3/2 is equal to 9 cubed to the power of a half. Now that requires you to know 9 cubed is 729 to the power of a half. And then you've then got to know the square root of 729, which is 27. Now technically they are both the same process and same thing, I think I prefer the top one with the smaller numbers. I don't know about you. And that's only with 9. I would hate to do things like if that was 27 to the power of 4/3. Then you've got to do like 27 to the power of 4, which is a big number. And then you have to do the cube root of whatever that big number is, which would be silly. So let's actually do that. 27 to the 4/3. I'm going to go down the route of the smaller numbers. So we go 27 to the power of third, power of 4. Well, that's the same as the cube root of 27. To the power of 4. The cube root of 27 is 3. Then we have 3 to the power of 4, which is 81. And that's a darn sight easier than going 27 to the power of 4. Which is quite a big number. And I can do that without a calculator that way around. So what happens if we have fractions? So let's go for something like 4/9 to the power of 3/2. Well, that is the same as 4/9 power of a half cubed, which is a slightly quirky way of writing it with all those brackets. But really what I'm doing is the square root of 4/9 cubed. Now the square root of 4/9 is 2/3 because the square root of 4 is 2, square root of 9 is 3, and then I have to cube it. 2 cubed is 8, 3 cubed is 27. Let's scroll down a little bit, and then let's go for something like, let's go for 25/36 to the power of minus a half. Well, if you remember a little bit earlier, we think, what does minus do? Well, the minus power, which I deal with first, so that just flips the fraction. So we have 36/25, power of a half, which is just the same as the square root of 36/25. Well, the square root of 36 is 6, and the square root of 25 is 5. So let's go for 16/25 to the power of minus 3/2. So when we have 16/25 to the power of minus 3/2, the first thing I do is I deal with that negative. So what the negative power does is it flips the fraction. So we have 25/16 to the power of 3/2. What we then do is you have 25/16, and we square root it. And then that is then cubed. So that's like 25/16 to the power of a half, which is the square root, cube it. The square root of 25 is 5, the square root of 16 is 4, and that is what we're going to cube. 5 cubed is 125, and 4 cubed is 64. So let's have a little look at when we've got algebra. So here we have 64x squared to the power of a half. And a bit like before when we had fractions, you dealt with each one separately. We're going to do the same here. So what we have here is you have basically square root of 64 is 8. And the square root of x squared is x. So we kind of then have just attached them together, which is 8x. Let's do 100 x to the 20, our half again. We have the square root of 100, which is 10, and the square root of x to the 20 is x to the 10. Now, with our powers, we are just multiplying, so we have 20 times a half, or half of 20 is 10. I wouldn't always bother with the bit at the bottom, but I'm just doing it for working out or showing you what we're doing. So then that gets you 10x to the 10. Or let's go for 8 x to the power of 30, y to the power of, let's go for 90 to the power of a third. What's that? Well, the power of a third is the cube root. So the cube root of 8 is 2. We go down. The cube root of x to the 30 is x to the power of 10. And the cube root y to the power of 90 is y to the power of 30. Because you're basically doing a third of the 30 and a third of the 90. So that gets you 2 x to the 10 y to the 30. So we might also have a question a bit like this. Now this is a little bit different. So we have 10x to the power of 4 plus 15x to the power of 3 over 5x to the power of 9. Now, we have dealt a little bit into this with indices a couple of exercises ago. But what we do here when we've got a fraction and you have it's just a single thing at the bottom and pluses at the top, because we can actually separate them out. So you have 10x to the 4 over 5x to the 9 plus 15x to the 3 over 5x to the 9. So we kind of separate them out into two separate fractions. Then we use our index laws, which is to do with all the indices, like I said a couple of exercises ago. And we do 10 divided by 5 is 2. X to the 4 divided by x to the 9. Well, what we do here with division is we subtract. So what we're doing is doing 4 minus 9 is minus 5. And I prefer just having negative indices rather than fractions. Plus 15 divided by 5 is 3. And then 3 minus 9 in terms of our powers is minus 6. You have x to the minus 6. And that is a better way to write it. But you could have also written it as 2 over x to the 5 plus 3 over x to the 6. And both are fine. Just often we would go for the first one and we wouldn't bother with that one there. But technically both are perfectly the same thing. So here we have another question, which is x cubed equals 27. Now, to find out what x is, when you have like x to the power of something, I know here we have x cubed is quite easy. But what we do is we take the reciprocal of whatever the power is, and then we take that to the power of everything. So let me show you. So we have x cubed, and the reciprocal of a cube, or reciprocal of 3, is a third. Then the whole of the other side, you do 27 to power a third. The 3 times a third is 1. So what we end up getting on this side is x to the power of 1, which is just x. Now 27 to the power of a third is the same as the cube root of 27, which is 3. So something cubed was 27, well that obviously was 3. But what about if I went x to the 3 over 2 equals 8? And we have to then work out what x is here. Well, the reciprocal of 3 over 2 is 2 over 3. So you just flip the fraction. So we have x to the 3 over 2 to 2 over 3 equals 8 to 2 over 3. 3 over 2 times 2 over 3 is the basic same as 6 over 6, which is 1. So this is how I go about it. So I would just then go, this is x to the power of 1, and 8 to the 2 over 3, if you type that calculator, or you could work it out, is 2. And it's the cube root of 8, which is 2 squared, which is then equal to 4. Okay, so here we have another one where we have numbers on both sides. Now, before we can do anything, what we have to do is get rid of this 2. So you basically need to have x on one side and numbers on the other. So I'm going to divide that by 2. So 2 divided by 2 is 1. And I'm going to divide this by 2 as well. So you have x, so 3 over 2 equals 27. Then we end up doing that, the flipping of that fraction. So we have 3 over 2, and we're going to have 2/3 here. So 3 over 2 times 2 over 3 would be 1. And then you have that 27 to the 2/3. Well, that side gets you x. And then you have 27 to the power of 2 over 3. So that's the same as the cube root 27 squared. So that's the power of a third. Cube root 27 is 3. So you can do a 3 squared, which is 9. So in this case, you have x is 9. So this next one, we have x on both sides. So instead of having we divide by the number, we're going to divide by an x. And it doesn't really matter, but I'm going to divide by x to the power half. And we do that to both bits. So this is like x to the half divided by x to the power half. So that then equals 1. And x to the power of 1, which is what this is over here, divided by x to the half. But what we're doing, we divide, we take away. So we have like x to basically 1 minus a half, which is then x to the power half. So what we end up having is 16 times 1, or 16 equals x to the power half. Then, to get rid of that half, we do the reciprocal of a half. What's the reciprocal of a half? Well, that's 2. So we have, on this side, I'm going to have x to the power half, power 2. And then I'm going to have 16 power 2. Well, that gets you x on that side, and on the other side is 256. Feel free to do some sort of other multiplication as well. So let's have a little look at this next one. So here we have 32 square root of x equals 1 over x squared. The very first thing I'm going to do here is I'm going to rewrite these with positive and negative powers and fractional powers. So I would write this as 32 x power half equals x to the minus 2. Now there's a couple of ways then to go about it. If we like positive powers, which are, I guess, a little bit nicer, I could then times both sides by x squared times x squared. So we have 32 x to the basically 2.5 or 5 over 2 equals 1. Because x to the minus 2 times x to the power of 2 is x to the power of 0. What we then can do is we can then get rid of this 32 by dividing. So we end up with x to the 5 over 2 equals 1 over 32. So we just divide by 32, both bits. What we then need to do is we then need to get rid of this power thing. And we get rid of the power thing by doing that reciprocal power. So we have x to the 2 over 5 over 2 in brackets, power of 2 over 5 equals 1 over 32, power of 2 over 5. That side gets you x, and on the other side gets you a quarter. Now the quarter comes from, you end up with the 5th root of 1/32 squared. Well, the 5th root of 1 is 1, the 5th root of 32 is 2, and then that's squared. And 2 squared is 4, so you end up with 1 over 4. Let's see if I can zoom out on that a little bit. And there we go, you can have a little look through that one. And I'm going to now put the questions on the screen. This is from exercise 1D. And I want you to have a go. So pause the screen and have a go at these questions, and see how you do. And in a moment, once we've put some of these questions on the screen, I'll also put the answers. But hopefully you've done all right and you understand these powers a bit more. If you're not 100% sure, do go back to exercise 1A, which is to do with indices and powers, because these are quite similar. It's kind of another step up.